Good evening, and thanks for joining us. Tonight we'll be looking at exploring what's typical using probability. My name is Mike Houston, and I'm the moderator of this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Tracy Watson and Don Wooster. Tracy has been teaching geometry, AP statistics, and AP calculus at Benton High School in Arkansas for the past 3 years. She has taught college mathematics courses ranging from basic algebra through calculus for over 15 years. She's been an AP calculus reader for 4 years and was introduced to the graphing calculator as a teaching assistant in graduate school and hasn't turned back. As a T-Cube national instructor, she enjoys sharing with teachers across the country the appropriate use of technology in the classroom. Tracy, thanks so much for being with us tonight.
Thanks, Mike. It's awesome to be here.
And Don is in his 24th year of teaching mathematics in both public and private high schools. In this time, he has taught all levels of mathematics. He is currently the mathematics department chair at Trinity Preparatory School in Winter Park, Florida, where he teaches pre-calculus, AP calculus BC, and linear algebra, his favorite. Don is also an adjunct instructor at the University of Central Florida, where he teaches statistical methods 1 and 2. He's been a T-Cube regional instructor since 2009. Don, thanks for joining us tonight.
Thank you very much, Mike.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Tracy or Don using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link for the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try finding your name in the participant window, and in that window there's a phone icon. Clicking on that phone icon will give you an option of switching your audio from the audio broadcast to using your phone, and hopefully that would clear up any potential audio issues that you're having. At this point, Tracy is going to discuss our agenda.
Okay, tonight what we're going to do, we're going to start off just trying to figure out how we can get ideas for activities and things that we can use for our students in our class. And that's going to lead us to an activity that I found called Roll the Dice, which leads us to the probability simulation app, which is really spectacular on the TI-84 plus CE. Then we'll move into a coin toss simulation on the TI-Nspire CX. And from there, we're going to look at 2 AP questions because they have some wonderful content in them. One of them is related to probability simulation, which we're looking at simulation tonight. And then we'll move to another one which looks at combining random variables, a fun topic that students struggle with. And then we'll finish off by making sure you know where you can get some more online resources. And of course, the chance to win registration to the T-Cubed International Conference in 2018.
Thanks, Tracy. And Don is going to discuss our expected outcomes.
Tonight, Tracy and I are going to look at 6 key concepts. One of the first ones we're going to do is we'll relate the concept of probability to corresponding concepts of statistics. We're going to look at examining probability as a long-run measurement. We're going to illustrate how technology can be used to determine probabilities through direct calculations and through simulations. We're going to investigate the calculation and interpretation of expected values. And we're going to discuss measures for random variables formed by combining other random variables. And we're also going to relate these concepts to the AP testing experience and using 2 of the questions we have found from previous years kind of show how it ties in. But we're also going to show you how these same questions can be used in the non-AP setting as well.
Dawn, thanks so much. Tracy, it's all yours.
All right. Thank you, Mike and Don. I think y'all should be seeing my computer desktop right now, and I am sitting on the TI's website, education.ti.com. What I wanted to do first is show you how when I'm teaching a concept, I want to get some new ideas to approach the subject with my students, especially some of the troublesome ideas, which one of them tonight that we're going to address is just what is probability? And do students really truly understand when they calculate a probability theoretically, what it actually means in practice in the real world? And so kind of tie that together. And so one of the first things I always do when I'm trying to find some new ideas is go to the TI site, and under their activities, there's two areas that I tend to target. There's a lot of different areas there. Tonight, we targeted the 84 Activity Central because that has activities that are organized very nicely for the 84. And then Don found something, getting his idea under the Math-Inspired, looking at those activities that there. So I'm going to go to the 84 Activity Central and just quickly show you the layouts because I think that's important. They have all the activities here that are very nice, clean, have lots of support for you in the different subject areas. So of course, we're doing statistics tonight, so I went to statistics, and then it's broken down into several different batches of categories of problems. And so because of our topic tonight, I went looking under the probability and random variables area. And what it'll give you is a nice, quick, brief look at some activities that are pre-made for you that you may like to bring into your classroom. And so first thing I always do is after I find my area that I'm looking for ideas, I just start scrolling down at the quick view. It lets you know brief description, a little quick screen capture of what the activity was. And so I looked through a couple of them to get ready for tonight to get some ideas. And the one that really jumped out at me was roll the dice. So I'm going to click on either the picture that goes with roll the dice or the roll the dice. And it gives me a little bit more detail of the activity that they have for me. They give an overview, and it runs through some key steps so you can get some quick snapshots of what would happen to a student on the calculator in the activity. Now, over on the side, you're going to find some files that are handy. And the ones that I want you to notice are the teacher notes. They give that to you in PDF, and then student files. And they're both as a Word document, VOC, and a PDF. I love the Word document because it's rare I take an activity and use it exactly as it is. And so I'm glad they provide the student side in a document that I can actually modify and adjust. And so what I did was I downloaded those when I thought I'd be interested in this activity. And I thought, okay, what am I going to actually do? I am not really good at following. The layouts are wonderful in these activities, but there's always things that I've done in the past or I have different students that always need to tweak things. And so I did the same thing with us tonight, but this was my inspiration. What I really saw in this activity was some of the theory and then running a simulation on the calculator. So each student can run their own personal simulation. So we're going to dive into it. I'm going to open up the activity. This is the PDF version of the student activity, just so that you can see what it's going to look like. And if you like this as it is, you can just give it to the student. It has students doing some theoretical probability and then talks them through if they're going to do something on the calculator. It does give them calculator steps, okay? So if it's a new area of the calculator you're working through, these will a lot of times talk you through the steps. Now, before I show you what I did with this activity for us tonight, I want you to see the teacher handout. Oops, that's not it. That's our AP question. Let's see, I must have not minimized it. There it is. There's the teacher PDF. I have learned from experience, I always read through this because there are things that even just looking at the questions from the student activity that I didn't think about because I haven't done the activity with my kids yet. So it talks about what's in the lesson. It lets you know the vocabulary they're going to use. It even lets you know what students should already be familiar with. And I think that's important. So what do they already have to have, the tools, the content, before this activity really comes into play? If they don't have it, then I might want to do a little quick intro on some material that we haven't covered yet that we need for the activity. So for this activity, students are already familiar with the concept of finding sample spaces and writing probability of events happening. So when you have your sample space, basically calculating the theoretical probability. So I kind of thought about that when I was working on this tonight. The other thing as you look through these teacher notes is the answers to the questions are here. So that way you can just double check yourself. And teacher tips, teaching tips. So sometimes there's things, because of people who have already used these, they've experienced, they wanted you to give a warning about things that can go wrong that you wouldn't expect. And so they're just kind of giving you some tips. And that I found helpful. So I know if it would happen, it kind of gives me the solution to it already, something that I might not have expected. So what I'm going to do is I'm going to open up my 84 over on the left. And on the right, I have my SMART open, but I just clipped out the one piece of the activity that I'm going to use for us tonight because we don't have time to do the whole activity. So the first thing I want to make sure that we're all good to go on so we can get to the simulation, which is the really cool stuff, is the theoretical probability. Again, I'm assuming students can do a sample space. And students typically come to me, I teach juniors and seniors in AP statistics, able to do some basic sample spaces. Now this one, 3 coins versus just 1 coin, a little bit more discussion with them, but once I get them to remember the idea of how to use a sample space to do some probabilities, they're usually pretty good at coming through and actually finding the probabilities that I want them to find. So the probability of not getting any heads when you flip a coin 3 times is 1 out of 8, okay? And then the probability of getting 1 head is 3 out of 8. So this is something that my students can do at this point. Now, that's the theoretical probability, okay? And they have, tossing a coin 1 over 2, the probability of a head. I mean, they can do that kind of stuff, but I found they don't really know what that means. I can ask them questions. So true or false, I flip a coin 8 times. These 3 coins 8 times, I'm going to get no heads 1 time out of those 8. And they're like, oh, yeah, that's what that means. Oh, no. And so they really don't get the difference between the theory and what actually happens. And so what I thought, after talking about this, I am going to get them to do, and don't look at this yet, and we'll come back to where this thing came from. I get them to do the picture, the probability distribution of this. And so the probability of 0 heads is 1/8. And so we're going to do a little bar, and we're going to say, okay, that's the height of 1/8. Come over there. And then the probability of 1 head is 3/8, so it's going to be something that looks like this. And then 2/8, they told me it was, or 2 heads, it was 3/8. And the probability of 3 heads is 1/8. And so I want them to not only do the fractions for the different probabilities, but I need them to have a visual of it, okay? Because what I'm going to do now is I want to simulate flipping 3 coins, and I'm going to visualize what's happening. And so now my students have this visual of this is the theoretical probability distribution for this flipping 3 coins and looking at the number of heads you see. And so now it's the perfect time for them to pull out their calculator. Now, I will say I actually will give them some coins and have them physically do it, but y'all know how loud this is going to be. And so we don't do it very long, okay, before we say, okay, this is too noisy, we're not able to concentrate or collect data, so let's turn to the calculator, which is quieter. Now, this app on the calculator, which is what this activity includes, the probability simulation app, is fabulous, okay? Now, if you don't have this app or this calculator that can handle this app, I'm sure there's a Java applet. There's an applet somewhere that does the same thing. But I really like the students having this in their hand. So we're going to go to the calculator now. I'm going to hit apps, and ProbStim is my probability simulation app. You are able to do 6 different types of simulations with this app. You can toss coins. You can roll dice. You can pick marbles. You can spin a spinner, draw cards, just do random numbers. So you have your choice of what kind of simulation you want to do. Now, I'm going to do my simulation of flipping 3 coins. So I'm going to go to simulation number 1. Oh, before I do that, I almost forgot. I got to talk very quickly about this seed that's sitting here. Humans do not do random very well. Computers kind of do, but they still follow a program. And so one of the things we have to be careful of, the random program that is used in the background to do these simulations is seeded. It has a certain number that it's used to start the randomness. If all of our calculators have been reset, we all are at the same seed. So when we do a simulation, we would get the exact same results. That's not randomness. So what I always have to have my students do first is to seed their calculator. So apps run by soft keys. So to select seed, I'm going to hit the zoom button, and then I'm going to type in a number. And I tell my students, type in whatever number you want into here. And I usually black out my screen so they don't know what number I'm using, because I don't want their simulation to work exactly like mine. Some people might like that because then we're all seeing the same thing, but then that to me kind of ruins the randomness, what randomness is. So now, if you saw it, so if you seed your calculator the same way I did, we're going to be looking the same, but you can handle it. You know that that's what the seeding is. So I do get my students to start off by doing that. And then now I said we want to simulate this flipping 3 coins. Now, one of the things that my students tend to do is they say, okay, well, if I flip 3 coins 8 times, I'm going to get 1 time with no heads. And that's what we want to show them, that that's not what this probability of 1/8 is telling you. So I'm going to select the coins. Then I've got to tell the calculator my setup. What specific simulation do I want to do? So I'm going to hit the soft key set, and this is where you can make adjustments. The trial set is the number of times you do the simulation when you hit toss. I like just leaving that as 1, and you'll see why. But if you wanted to toss the 3 coins 20 times right away, you could change that to 20. I like leaving it 1 because it does give me some nice options if I do that. I want to use 3 coins. I'm going to select the 3 coins. And I'm also going to store all the data that I collect in a table. Okay, and I'll show you why that's going to be handy. Everything else I'm going to look the same. I'm going to hit OK. And I was playing with this before, so it's got some settings. Okay, that's fine. Change the settings. Now I can click toss. And you can visually see 3 coins of being tossed. I got 3 heads. So what I like to do with this is I'm going to toss 8 times. In the upper left, it's counting how many times I did a toss. So I'm just going to get it. So I've tossed my coin 8 times. And what I'm wanting students to see is when I do that, this distribution of what actually happened does not match the probability theoretical distribution, okay? That's because probability is what happens in the long run if you repeat it again and again and again. And so some students are like, well, that if you do it 16 times, this will happen, then it will match. And so, of course, I'm going to get them to do it 16 times. Of course, they like multiples of 8 here. Oops, I did 17. And, well, that looks really different. And now this plus 10 and plus 50 is when you can do it a whole bunch of times. I'm going to do that 10 times with one button, 50 times with one button. So you can get a better picture of what's physically happening in the long run, because that's what a probability distribution is telling us. So I'm going to go ahead and hit plus 50 a couple of times. And in the long run, this should be what I'm seeing, the distribution should be approximately what the theoretical is telling me. And so I can just keep hitting it. It's never going to be perfect, but it's going to get it approximately. And so I can even get it. Now, physically with coins, you could, well, you could ask students to flip it 500 times, but usually after 20 times, they start just making up numbers. At least that's my experience. When I assign them to do it 50 times, they do it 20, and then they start just making up numbers, so it's not truly random. And so by going 517, it's looking more and more like the theoretical distribution, what theoretically should be happening. That idea, I think, gives them a better feel for what these probability numbers actually mean, that they can usually come up with because they've seen things in classes before, but they truly don't understand it. So 1/8 of the time you're going to get 0 heads? No, that's not what it means. So now the other thing, let's see, that I want to do with this to show you is this data that I have. If I hit the table, notice it's been keeping track of everything that's going on. I asked it to keep all of the data. And so I have what happened on each individual toss. And what I'm really interested in is the total heads, okay? And so one of the things that I can do is outside of this app, I can actually do things with this data. So if I want to do that, then what I have to remember to do is hit the data soft key and then tell the calculator, yes, I want to save this information into the list outside this app. If you forget to do this, then you got to go in the app and run it again. So it tells you, it lets you know which list all of that data is. Now, tonight, all I'm interested in is the last one, the total heads. So I've got my data, it's going in list TOTH, and that's why I put it down here over on my smart board so that I can see that data. Now, before we leave this app, I need to show you a few other things that you can do with this. So I'm going to get out of this coin toss simulation, but even when I do this, this data is outside my app and my calculator, so I'm not losing it. And even though it says it's clearing from memory, it's not clearing it outside the app, thank goodness. And I want to go down to rolling dice, because there's some other things that when you're doing simulations you might want to be using that is in these with the different types of simulations. We don't have time to do all of these, but I do want to show you a feature of the roll the dice. And actually, it's also a feature of the coin toss. I just don't think it's as interesting. Okay, and I'll tell you that in a minute. If we go to the set, again, remember, that's when you're setting exactly how you're going to do your simulation with dice. There is a soft key called advanced, okay? So this is doing your setups. How many dice do you want? Oh, this is so cool. How many sides do you want on your dice? So you don't have to use a standard 6 dice. But under advanced, what you can do is you can weight the dice so that you don't have a dice that has equally likely outcomes. Right now, it's a fair dice, but you can start messing with this. And I'll do this before my students come in on my calculator. I'll run a simulation and I can ask them questions like, do you think this is a fair dice? So if I change this weight to 2 and this one to 2, now I'm just going to do one dice for ease. My probabilities, there's not too much of a difference. And I do this with them. I'm going to hit OK. I'm just going to do one dice. And I'm going to start rolling. And I'm going to go right away to the plus 50. And I ask them, do you think I have a fair dice? And some, oh, maybe, not sure, you know, they might think that is a fair dice, especially if I make my weights not as subtle, okay, or make them more varying or less varying. And so you're able to kind of get them to understand what it would be. And I would also do this, you know, with it being a fair dice I'm going to come into. But I wanted to show you that you can weight your dice so you don't have equally likely outcomes. And that can use to simulate a lot of probability problems that you have because you know some information. Okay, now, so I don't get too off on a tangent, I'm going to escape out of this. I'm going to quit out of this probability simulation app. Am I sure? Yes. And there's two things that I want to do with you. First, I want you to see that that list, the TOTH list, my total of heads list, is actually there. So I'm going to go under Stat and Edit, and I'm going to go up, and in my blank list, I'm going to grab, and so that we can physically see it outside the app, make this the list total of heads. I'm not sure if you've seen this before, but I can do second stat, and it gives me all of my list names bottom. And if I select that and hit enter, there is all of the total of heads from those 500 and some things that I did. Okay, I think I did 500 lists. And so I can do some stats with that. One of our objectives was talking about expected value, okay? One of the things we talk about is we have a formula for expected value. What would you expect as far as the number of heads when you toss 3 coins? And so one thing that I did earlier, and it's still here, is I used the expected value formula for the number of heads when you toss a coin 3 times. And we get 3.5 or 1.5. Now what we can do is we can actually compare that to the data, our simulation. Should it be 1.5 exactly? Well, let's find out. I'm going to ask the calculator to find the mean of that data. So a couple different ways to do it. If I can go to stats, I like running, just because I do other statistics, one variable statistics on lists. But there are multiple ways to do this. But I think I really just wanted to show you that that data is outside your app now that you can use from your simulation. I already gave it the list earlier, so I'm just going to ask it to calculate. And then I can see, eventually, there it is, 1.42. So theoretically, 1.5 from the simulation I got, 1.42. If I did more and more than 500, what I would expect in the long run is that this is going to approach 1.5. So I hope that kind of gives you a feel for how you can use this probability simulation app and connect it with the theoretical. I think it's very, very important for students to do simulations, okay? And so, and I'm doing a lot more of them this year than I've ever done before. And I think it's paying off. We'll see. We're having we're in confidence intervals right now, and so we're struggling a little bit with the different types of confidence intervals. They're starting to get their formulas mixed up, but you know, that's pretty typical. The only other thing I wanted to mention for those of you that are big 84 users, and because in just a minute we're going to go over to Don and he's going to do something similar on the Nspire, is how you graph this on your calculator. My only tip, because I have this data now that is the number of heads from tossing a coin 3 times. And in your calculator, you can do a stat plot of histograms. And so hopefully you know when we go to the stat plot of histograms, this third type is a histogram. I would make my list, that list that I got from my app, and then I can graph it. My only tip is normally we do Zoom 9, and it might not look exactly like you want it to look. I have 2 window settings here. And so my suggestion is let your X-min and X-max be like 0 to 4 for tossing coins. And your X scale, that's going to give you your size of your histograms, 1 for this one. And then this one I made it 0.5 to give it this look. So it kind of depends on how, this is a little bit more proper look of a bar graph, which is what we should be doing since it's discrete random variables. And so AP statistics, I do have to be a little careful, and so I'm manipulating it to get the calculator to do what I want it to do. But these are the settings that I would need. Now the Y max, I may need larger because I don't think I did 500 earlier. And this picture was only from doing maybe, I don't know, 200 or so. So I may have to adjust that. But if I go to my window settings, I could very quickly change these. Doesn't take too long. And then that also, oops, I love the go-to. That also helps me see, okay, I want my Y-min to be 0, and we're going to go to 40 with the scale, and then just hit graph. And so that matches what the probability simulation app gave me, basically. And then again, I can use that to compare what I drew by hand. So they're not exactly matching, but if I do more and more in the long run, we should be getting close to the same kind of distribution. So I'm going to pass it over to Don because he's going to do something very similar related to it on the Nspire. So there you go, Don.
Great, thank you, Tracy. And just what I'm going to really just follow up what Tracy did on the 84 with the TI-Nspire. But what we're going to do with the Nspire, we're actually going to build it. I'm going to show you how to build a simulation within the document itself. To kind of do what Tracy did within the 84 app, we can do the same thing with the Nspire with slightly different approaches. So the first thing we're going to do is we're going to create a new document. And just as Tracy did, we're going to start off with that random seed. Because what we want all the students in the class to have their own data, because the ultimate goal is I usually have them in groups when we're doing this in class, and I want them to compare theirs, and I do not want them all to have the same results, so it brings up this great discussion. So on the Nspire, on a calculator page under the menu, we can look for probability, and under probability, we see that there's a random option, and under random is where we can find seed. And then just like the 84, you can type any number that you would like, and every student, I just ask them to choose their favorite number, type any 5-digit number that they want, or 2-digit, it really does not matter. When they press enter, now it is seeded for that, so hopefully nobody picks the same number, so we all can get different results. To do the simulation in the Nspire, what we're going to do is we're actually going to use a list and a spreadsheet page. So I'm going to insert a list and spreadsheet. Very similar to the list in the 84. A couple key exceptions. One, it's more kind of Excel-ish, I guess. So we're going to give them some headers. We're going to call them, we're going to flip 2 coins instead of 3. So we'll call this coin 1. We'll call this coin 2. And then here in this bar right there, right on the equal sign here, that's where we're going to enter a formula. So we can actually calculate or actually just select random integers. So on the Nspire, we're going to define certain integers to represent heads, certain integers to represent tails. We're going to simply go with 0 and 1. We'll use 0 for tails, and we'll use 1 for heads. That way that kind of matches similar to what Tracy did with the 3 coins. So we have our 2 coins. We can press enter and notice a formula, kind of a coin 1, then you got your colon equals, so it's ready to be defined. So we're going to go into the menu. We're going to go into, oops, sorry, that's not. We're going to go data, then we go to the random. And then we get a bunch of different options here. We're going to pick integer. So the way the command works is you put your lower bound, integer, comma, your upper bound, comma, how many trials you would like. We're going to pick 100 trials for this evening. If you forget the commands for random integer, that it's lower bound, comma, upper bound, comma, the number of trials, if you go into the book here, to the catalog, and you go and you select the command random integer, it will tell you exactly the commands that, the order to enter them in. When I press enter, it has now given me 100 random flips. So the zeros are representing our tails, and the ones are representing our heads. We kind of scroll through, we can see they go all the way down. We'll do the same thing for coin 2. So we're going to go to the menu, data, random, and again, integer, 0 to 1, and we're going to pick another 100 of them. So there's our second coin and its sample. But now we want to look at how many total heads did we get in the 2 flips of the coin. So in this third column, we're going to do a sum of the first 2 columns. So we can call this heads, so that can help us remember that this represents the total number of heads in each of the flips. So in the first flip, we had 1 head. The second flip, we had none. Then if you notice in the fourth flip, we now have 2. So for heads, we're going to press enter again. And now we want to add those 2 lists. We want to add this cell to this cell. So we're going to press variable key. We're going to pick the headers, coin 1 plus, press the variable key again and pick coin 2. When I press enter, it has now summed the column. So right now, we just have the raw data already in table form. When you start with the 84, you start with a table, then you're exporting it into a list. On the Nspire here, we're creating the list first for the raw data, and from here, we're going to build a table. There are 2 ways to build a graphical display for this. I'm going to show you one method that is easy to share with other students, and another method is going to help us make this table a little more meaningful. So the first thing I'm going to do is I'm going to enter in the data and statistics page. So when you enter in a data statistics page on the Nspire, you have all your random observations there, and you need to tell them You need to tell the program what variable you'd like to add. So I'm going to click down here, and I'll pick heads, so we can get the total number of heads in those two coin flips. Now the default, if you notice, they've done the default scale of 0.4. Probably not the most elegant looking scatter plot here, or dot plot, sorry. So what we could do, if we go down here, now if you're using your handheld, on a computer it's a right click, so on a handheld it is Control Menu. We're going to pick number 1. We're going to make it so it's categorical. So when we do that, notice now just falls down into 0, 1, and 2. At the same time, notice each one of those dots represents one of the observations. And one of the things I really like on the Nspire, if we go into Menu, notice we can change the plot type. So if I press number 1, notice right here my bottom 3 options, those are my categorical. So since I have forced categorical in there, notice my choices are dot chart, which we currently have, so it's grayed out, but we can change this into a bar chart. And when we do that, the students not only can see the bars, but they can also see all the dots kind of going into the bars and making the individual bars. And if we kind of hover over them, they tell us there were 31 times out of those 100 that we got 0 heads. There were 46 times that we got 1, and there were 23 times that we got 2. So at this point, the students are in the group, they've built their graphs. I want them to share, talk about the similarities, the differences, what do they notice. If you have a navigator in your classroom, this is where I kind of would do a screen capture of the students' calculator, so you can kind of look at the whole class up at the board, and let's see if anybody kind of stands out one way or another, a little bit different, and start talking about why it's not matching up with our theoretical probabilities that we had talked about earlier. If I go back to the previous page here, one really neat part about the Nspire, I've got those 100 observations. If I press Control and R, it reruns the 100 simulations again. So I have 100 different trials. If I go back to page 3, there's my new data with my next 100 observations. I now have 24, 50, and 26. I don't think if I tried, I would probably get that close again, so not too bad. But we're flipping screens back and forth. I like this big data statistics page when we're looking at it. But if I'm going to keep running it over and over again, on the spreadsheet page, whatever column you would like to make a quick graph of, if you're in that particular column, go into Menu, and under Data, notice number 9 is a quick graph. And it gives us the same thing we started with on the data statistics page, but now we have a split screen. We have our raw data on the left, we have our graph on the right. And just like we did before, we can change it back. And then if we wanted to, we could go in and we could change it to a bar graph or even a pie chart if we wanted to. And just like the bar graph, we can still hover. Now, I'm going to switch this back for a moment to the bar chart. So if I click back over here on the spreadsheet page, and I press Control R, for a little adjustment there. Control R again, more obvious. But as this changes, right next to it, the students are quickly seeing how their data is changing. The number of no heads went up on that one, and the number of 2 went down. And we could do this a few times. Now the number of heads has gone all the way up to 56. And we can fix our window. So if it's not in our window, we can go to the menu. I'm on the wrong screen. Here's something that's easy to do when you're on the split screen. If you notice there's a border around this side, that's the screen that's active. If I want to make edits over here, I need to make sure that this side is active. So under Menu, now Window and Zoom Data, and it will now scale it up to just over 60, so we can see the full bars. So the big difference between the 84 and the Nspire, the 84, you're starting with a graph, you're going to the table. Nspire, we're kind of going in the opposite direction. What I would like to do now is kind of take what Tracy and I have done about tossing the coins and look at last year's AP stat exam, question 6, the problem-solving one. I'm not going to do all of this. I just want to talk about a couple different pieces and how we can take the question they're asking, change it up for in class, and then talk about how we can turn this into a simulation problem. On this very first one, they had to set it up for men and women randomly assigned to a treatment or a control. And what happened, the people were identified as man 1, man 2, woman 1, and woman 2. So 2 possible methods of assignment are being considered. The sequential coin flip method, as described in Part A, and kind of the coin flips that Tracy and I have been doing with the simulations this evening, and the chip method in Part B. For each method, the order of assignment will always be man 1, then man 2, then woman 1, then woman 2. That's kind of the important part here. Is each coin flip or chip selection is defined man 1, then it defines man 2 in the next, and so on and so forth. So in the coin flip method, a fair coin is flipped until one group has 2 people. An outcome of tails assigns that person to the treatment. An outcome of a head assigns it to the control group. As soon as one group has 2 people, the remaining people are automatically assigned to the other group. So if we kind of look at the arrangements here, since we go in order of man 1, man 2, this one had to get the treatment both times. So there had to be tail, and then we were done. But on this one, the man 1 was here, man 2 ended up over here, and then woman 1 is back at treatment. So that had to be tails, head, tails, and kind of so on and so forth. So what I have done here is I've kind of listed out those options here to show the theoretical, 1, 4, 1, 8, 1, 8, 1, 4, 1, 8, and 1, 8. And the question asks for, what's the probability that man 1 and man 2 are assigned to the same group? Well, that's either going to happen if they're both in the treatment or if they're both in the control. So it happens 1 and 2. Here, they're asking us to calculate the probability of this, the theoretical. We could easily set this off either on the Nspire or on the 84 to treat this like a simulation. Look at the simulations, how close are they as we increase the number of trials, how much closer we get into the theoretical, and talk about that long-term process again. And on the chip method, basically now you're getting 4 chips, but now you're doing it without replacement. So what's happening now, 2 are marked treatment, 2 are marked control, and it's still man 1 gets the first chip, man 2 gets the second chip, woman 1 gets the third chip, and woman 2 gets the 4th chip. Once you fill a group, everybody else goes in. Well, what we notice, since this is without replacement, the 2 treatments in a row is now going to be 2/4 and 1/3. because now we only have one of the treatment chips left, and there are only 3 chips left in the bag. The second one would still follow the same pattern, but now it's treatment chip, control chip, treatment chip. So it's 2/4, but there are still 2 control, so 2/3, 1/2. Notice each of these are equally likely to happen. If you wanted to simulate something like this on the Nspire, I'm going to go ahead, I'm going to start a new problem here. I'm not going to reseed it right now. I'm going to kind of list the options. So for our chips, we're going to let chips 1 and 2 be the treatment, 3 and 4 be the control. And when I insert a calculator page, I can take a random sample from that list. I'm only going to pick 3 of them, because really the 4th one you don't need, but if you want, you can pick all 4 of them. But I'm going to add one more option in. I'm going to do comma 1. What that comma 1 does is it will take a random sample. Actually, let's leave it at 3, comma 1. If I choose 3 of those chips at random, that comma 1 means they're not going to repeat any of those numbers. So notice here I get 2 control chips right off the bat. So both men end up in the control, then the women would be in the treatment. And on the next one, notice the order this time is control followed by 2 treatments. So the students could then do a random sample of those chips, look at their data, and construct a graph to see what this is happening as well. This has a lot of stuff outside of the theoretical that they're asking that you can build it into the random sampling. And to find the random sampling under the menu, it's still under probability, and it's random and sample. If you're using your teacher software, you can just type rand sam. Okay, I'm going to send this back to Tracy so she can look a little bit at linear combinations.
Okay, we don't have a ton of time, but I do want, because part of our agenda was looking at some random variables and combining random variables. So I think I'm just going to point you into the direction of the problem that I like. Students have a really hard time finding random variables, the linear transformation of a random variable and then 2 separate random variables, and understanding the connection between the expected value and standard deviation and variance. And so I've got on the screen just the formulas, and when students are in the section, they're great. They can do this for the most part. They'll forget when it's a difference, you know, they'll subtract variances and all, but, you know, in the section, they're awesome. But then when they get out and on a test, which will be my test this Friday, we'll have this, they're going to, they forget and they freak out. They don't notice a problem that has multiple random variables and that they've got to do this. And so I actually gave this question, I had a review session after class today, or after school today, and gave this AP question to them. Now, I don't know if anyone got to it because most of them were working on the homework too, but they do have this, and I'm toying with just throwing this on their test on Friday. The first part of it, it's 2013 question 3. The first part A is just a random distribution problem. And so if you've done random distribution, I've done the problem, you know you can get the calculator to do those values for you. That's the beauty about in this class. The calculator's doing a lot of the calculations that when they take calculus statistics, you know, they'd be doing all that by hand, but we've got the calculator to calculate areas under curves. Oh, I just noticed the only thing I forgot on here that I would require my students to do is to shade my area. Mark that 850 down there and shade the area. So the second part, though, is the part that I think is awesome for if you want to target the combining of random variables, because it's linear transformation and combining two different random variables. Because you've got a carton of eggs, you've got information about a full carton with 12 eggs in it, you've got information about the empty carton, that means no eggs in it, and then your question is about the eggs, the 12 eggs that are in there. And so you've got these 3 different random variables, and they give you information about 2 of them, and you got to find the mean and standard deviation of the third. And so here's my work. I think the key is getting them to see that, oops, I erased, I didn't want to erase. The connection here, getting them to see that what they're talking about is a combining of random variables. And so all I'm going to say is, if that is problems you need them to work on, look at this one. This is 2013 question 3. And all these AP problems you can find online. They're the released ones, and I use them left and right. So I'm going to go ahead and hand it back to Eric, or he'll take it away, because he can probably take it away quicker than I can give it back.
I got it, Tracy. Thanks. So we are going to begin wrapping things up tonight. If you have any last-minute questions for Tracy or Don, please try to get those asked. I know they'll do their best in the last minute or two here to try and get those questions answered. Earlier, Tracy had mentioned at the very beginning tonight that tonight we're giving away to one lucky winner a T-Cubed International Conference registration for the T-Cubed Conference in San Antonio this coming March. I think it's a great place to, again, connect with fellow educators and people that are like-minded. And tonight's lucky winner is Charles Frederick. So Charles, congratulations. We'll be in touch over email in the next couple days to give you a little more information, but we really hope to see Charles as well as everyone else at the T-Cubed International Conference coming up this coming March. I saw on tonight's webinar, Steve Phelps was joining us, and coincidentally, Steve is going to be one of the 2 panelists for next week's webinar titled Effective Modeling with Geometry. So if that's something that might pique your interest, join us next week. We're getting closer to the end of our fall webinar series, but we just still have a few webinars left. So again, please feel free to join us next week for some modeling with geometry. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents tonight, so all the documents that were used by Tracy or Don, including the questions, the AP questions, are listed in that documents link. And in case the links aren't working for you tonight, have no fear, you'll automatically get a follow-up email. And in that follow-up email will be 3 different links, one for the recording, one for the certificate, and one for the documents. And if you happen to be watching this on demand, just go ahead and click that, write down that link and paste that into your favorite browser to receive your certificate. Thanks so much, Tracy and Don, for everything you shared tonight. We got a lot of great comments in that chat window, and it was really great to see some excitement, especially about some of the AP problems that you used tonight. So thanks so much for everything.
Thanks. It was great being here tonight. I had a lot of fun.
Thanks. It was a great night here as well.
And thanks again, everyone, for joining us. We hope to see you back online next week. Have a great night.